So getting data represented in a picture, because that's more can influence better than a list of numbers, people that are looking at this data in picture form. So a third picture you could do is a bar graph, and you already started writing all this stuff down. You can read, your adults. This first one is a survey, so it's not the grades that we had listed yesterday and putting it in a some sort of picture. And because it's a survey, there's really no connection between having your highest thing is a high school diploma, your highest degree is a bachelor's degree, so the bars are not connected. All right. But anyway, you can read, and then here's a simple bar graph denoting from a survey of asking people what's your highest degree you have achieved. You're actually in none right now. Anyone know where I'm at? Am I Dr. Danny? No, never will be. What do you think I have? Master Samulus will be my title from here on out. Nice. All right, Jedi Sam. I like Jedi Samulus better. Thank you. All right. Oh, I left this here. You know what? Let me pause for a second. All right. There. I hid what I wanted to hide. I forgot. I didn't have my hidden notes set up here. Okay. So, and then you could ask silly questions off this bar graph. I'm sure we all could read a simple bar graph and answer questions from it. That's a really basic, concept. I hope. So just denoting that, you take the survey, then you put it in a bar graph so you can see who has, on average the most, and its bachelor's degree is the average. And I'm sure these are adults, I would think it was. I didn't really remember what the reading was. Then you can be asked silly little questions. What percent of the people surveyed had a bachelor's degree or higher? So what do you have to do? What do you have to do with all these numbers? Add them. And then what do you have to do with these numbers? Also add them, and then what do you got to do with the two numbers? Divide them, and then come up with a percent. Mickey Mouse stuff. Pause video. Resume. This should actually be like number 4. 3 was, and again, 1. We showed you 2 ways of putting data in a picture yesterday, so that's why there was a 3 next to bar graph. I guess this is 3B, a type of bar graph, but it does get more complicated. Not very much so, though. It's a special bar graph. Use the graph quantitative data, big word. And you use intervals to group the data, which hence shall be called bins. And the frequency, again, is how many times the data points or the data occurs in each bin. Okay, so we list our same scores from yesterday, meaning it's that test scores. Remember, we talked about the person getting a 6%. What are you doing? All the way up to a 97%. You'll find out what that word is. And then everything in between. First of all, you have to select a bin size. For grades, it makes sense to go by tens. Because what's a 90 to 100 represent? And that's actually 11, by the way, right? From 90 to 100, if you count, that's 11. But I'm going to make a little change, like verbally, in what you see in the chart. And then 80 to an 89, that is 10 spaces, by the way. 80 is 1, 80, 81, 82. If you count, that's 10. So 80 to 89 is a B. So for grades, it does make sense to have a bin size of 10. And what you do is you create these bins and figure out how many numbers occur within each bin. So what I'm saying is you probably should change that 99 to 100, even though that is 11. Someone could have got 100. So that's the one unique thing. I know all of these are Fs, all right, but let's see how bad some of these Fs are. Okay. All right. So this is what I told the first hour. That's why there were some crosses through this. I guess the way I did it is how many occur from 0 to 9? You go through the list. There's 1. And then there's no others. So I have 1 that occurs from 0 to 9. I have none and none and none that occur in these three bins. But from 40 to 49, 40 to 49. This is just to help you so you don't make a mistake. I have three of those, and then I cross them off so I don't have to look at them again in order to do the next bins, how many are in each one. So you do the frequency of each bin, how many numbers occur within each bin. And then that's what you graph. And then this makes sense that this graph is, a bin is connected to another because this is from 70 to 79. This is how many people get a 70 to 79. Then the very next one is from 80 to 89, 3 people. So this is these bars are connected. The survey, there was no connection between having a bachelor's degree or having only a high school degree. I guess they could be connected, but they really shouldn't. So making a deal out of something that really isn't a deal. Okay, so I'll give you a minute to take that down. I really don't think this is rocket science, but just know how to do the process, I guess, which is your job. Okay, now this goes to, I'm going to use the word manipulation. Remember what I told you yesterday? I found this the most powerful thing of this whole chapter, and it's actually going to dictate, what I talk about the rest of the chapter. How you can not manipulate the data, but manipulate the picture to make it look like you want. Take the same data and change the bin size. And that's what I'll show you next. That's already pre-completed. So we can take this data and change the bin size to 20. So that means let's group them by 20. 0 to 19, 20 to 39, 40 to 59. I almost screwed that one up. And so on and so on and so forth. You can see you get a bunch of different numbers as far as what would fit in there. Now, you can or may not want to put this down. It's up to you. I think you can handle the situation whatever way you want to. So how many grades happened from 0 to 19? It was only that 1/6 again still. How many grades happened from 20 to 39? That was that whole grouping of that didn't occur. But then when you look at the list, now again, you're going to have to look at the list up here. It's the same list. I really want to make a point of that. How many happened from 40 to 59? It's 4. 60 to 79, 6. And then 80 to 99, it's 5. Now, I know this is just a simple test score example. But just imagine if this was an example of some state senator trying to prove a point about these numbers. Look at these two charts. You have to understand that these two charts look completely what? Different. They just have a different aesthetic look. So that's why, these people that are trying to put some stuff together, they may have a professional statistician that's able to come up with various graphs with various parameters, and then the person that wants to send this out say, I like this one the best. This one proves my point. I mean, this one's more, I think this would be more powerful to prove my side of the argument. Make sense? Now, I know this is a Mickey Mouse example that doesn't really pertain to that particular situation, but I do love that concept. And you as a consumer, and as I called you, the common man or woman or whatever, all right? You should be aware of that now. I told last hour, I swear to gosh, I do have a lot of anger in my life. I'm trying to work on it. But there are a lot of times when I watch TV and I see what's projected, I am educated, I get ticked off that I know I'm being manipulated. And I know I'm being manipulated, and then I look at it and say, you know what, I get that. But then I think, you know what, I wonder how many people don't get it and are actually swayed by this manipulation. I'd just like you to think about that as you are adults yourselves when you see things. Right. Don't write this down, but again, to hammer down that point. This is a different list. I think you get it, but I just wanted to show what the book projects. And actually, it was from that reading alone that I am steered in this direction as your teacher about the possible manipulation. Different set of numbers, okay? And then I kind of made a mistake, but I cut this after they did a bin size of 10, then a bin size of 20. And then they said, hey, let's change the bin size to 5. That makes it smaller and makes the data more, there's much more bars. Different set of numbers though, so this doesn't correlate to your example that we have at this point. Just watch this and see that from the set of numbers, these are the exact same numbers, but this is the graph when you change the bin size to a 5. This is when it's a 10, and this is when it's a 20. Now again, these don't match your graphs because these are different numbers. Well, look at those graphs. They are completely different looking and express something different in each case, I would believe. So again, this is their words. I'm actually don't worry about that red graph. That's what we're doing next. And I shouldn't even have it in there. I didn't go back to it in any of the other classes. But, they say it. In histograms, the 3 that I showed you are those 3 figures. Bin size 5, 10, 20. Represent the same data, yet give very different views of that data. Thus, when creating a histogram, choosing an appropriate interval size is an important first step. Or choosing the appropriate interval size to get your point across, the one that you want to make. That's depending on the person. Okay, then one more thing. So if anything, the math is nice that you learn. Learn all those other little nuggets from Samuelus. It's true. How this world works. Okay. Then this is actually 3C. 3 being 3, you can represent data by a bar graph. This is a bar graph that's called a relative frequency histogram, which really is just a minor difference. It's not a big deal when I look at it. I should make a point in the video at the end of this. That red graph I said don't look at with those other different numbers. Or actually compare this to our bin size of 10 question that we did. I could do that real quick. We got to understand what a relative frequency is before we can do a relative frequency histogram, which is not a big deal. Just changing one thing. We're going to go back to the bin size of 10. So again, you have to understand what is the bin size and then make it happen. All right? But the reason I had to find out how many grades is you got to know what a relative frequency is. And all it is finding the decimal portion of what the bin size represents compared to all the rest. So it's a decimal found by the fraction number of grades in the bin itself divided by the total number of grades in this data set. So because we're going back to the bin size of 10, I'll show you what this relative frequency histogram looks like compared to just the histogram in bins of 10. They're going to look the same, relatively speaking, as far as the bar heights. But what you got to do is this. So again, let's go back up to that one. Hey, go back. No. This was our frequency table of just how many times these grades happened in the bins. What am I going to do with this 2 now if you took those notes and understand them? I'm going to take 2 and do what with it? Divide it by 16. I'm going to take 3 and do what? Divide it by 6. 6 and do what? And then obviously 0 divided by, which is still 0. So your chart looks like this. So if I ask you to do both, what I'm saying is you could go to the histogram that's on bin size 10, get these numbers and just divide them by 16 to get these decimals. Then the change is only in the vertical axis. The vertical axis is now not the frequency of how many times these things happen. It's the decimal slash that could be turned into percentage, right? This 37.5 means 37.5% of the numbers fall between 70 and 79. So the vertical axis now is the percentage or the decimal that represents how many times it happens compared to all the other data. Now, as you write this down, look at your regular histogram. Aren't the bar size relatively the same? I mean, they are. And that's what you'll see. It still gives you a correlation of all the data, how they compare to each other, bar size-wise. And then I did ask first hour, I forgot last hour. Why should these decimals add up to 1? Because what does 1 represent? What does that represent? 100% of the data. 100% of the data is covered. 1 represents 100%. I'll pause. Okay, and then the last thing is just a bunch of terms. When you look at these bar graphs, these are some descriptions. Is the histogram uniform? Now notice it doesn't have to be like every number is the same in every bin, but they're relatively, pretty uniform all the way across. There's not much shift from one bin to the next. Pretty uniform histogram. Symmetric, I think, is obvious. Actually, this is what we're looking for as a teacher. And then some classes it happens and some it doesn't. And then I have to look at that class. Why didn't this happen? Oh, this Jamoke sleeps every day. This second Jamoke stares at ceiling tiles. This third Jamoke comes to school 1 day a week. That's why this fourth Jamoke, what would he do? Never mind. I want to get into that. Okay, but anyone know what a teacher's looking for in the middle? What grade? What grade? Yeah, that'd be great, but it's usually the bell curve number is what? 75. It's usually right around there. Yeah, your class averages on the final, I think, was in the higher 70s, which is what we're looking for. So it wasn't too bad. Although I had to give you 3 or 4 questions, remember? Yeah, my fault, not yours. Okay, and then skewed when the data skewed to one side or the other. I guess this would be favorable for a teacher, but then we got these guys down here still. All right, and then, this is kind of a pain to do because you'd have to list the data in order. The center of the data is just the median. We know that. But what a pain is, how do we get 76 in our data that we've used 2 days in a row? We'd have to list it in order. By the way, there's 16 numbers. What numbers are in the middle? Is it 1 number or is it 2? It's actually 2. It's the 8th and the 9th number, right? So how do I find the number, the median, when it's the 8th and the 9th number? It's very simple. Add them in, divide by 2. But apparently if you list these numbers in order, remember there was 4 76s? Probably 76 is both the 8th and the 9th number. So that's why the median ends up being 76. I hope that's true. We didn't check in any of the hours. I think it is. I think at some point we should have put these in order, but we didn't. Oh well. All right. This is not a minus sign. This is what's the spread? And all you'd say to the person, the spread is from 6 to 97. Period. End of story. This is not a minus sign. So I guess I should change this to 2, lowest to highest. So it goes from 60 to 97. Whereas the next thing is what's the range? That is the difference between the highest and the lowest. That is a subtraction. So just be aware of that. And I'm done. Mark it.